Hey everybody. So this is a research paper that caught my eye called Can One Domain Help Others? A data-centric study on multi-domain reasoning via reinforcement learning. And this particular research paper is all about GRPO, which is in the realm of reinforcement learning. Very specifically, it's in the realm of reinforcement learning with verifiable rewards. And this particular research paper dives into and discusses GRPO very specifically and all around LLM models. And then so I'll start off the research and start off there, right? And then so GRPO, reinforcement learning, like all of these types of different training concepts are relatively new overall. And there's some people that I'm sure like instantaneously will jump on that, right? And say like, reinforcement learning has been around since like the 1990s, which would be very true, right? Like 1,000,000%. The concept of it has been around since the 1990s, and then you're seeing more and more people pile onto it, right? Like as soon as ChatGPT came out, one of the very first things that I was like propagating and saying that should happen with these models is reinforcement learning, right? But being like too early to the party, that means that like people don't understand that concept. Like what is this reinforcement learning? Like people, there was a period of time, like it's kind of crazy now, right? Where like people were like the only way that these models learn is via just being fed data, right? And then like if you don't just feed them data, then there's no other way that these models will actually do anything. And then you had to like disprove that and then go through that, and then now we're here, right? And then it's obviously like, well, like yes, obviously this method of treating them like world models that actually have an environment and then giving them essentially an environment to interact with and reward off of. I mean, that's essentially what GRPO breaks down, right? To does actually matter within this instance. But there's a lot to dissect very specifically within this research paper, right? So this research paper, very specifically what they do as far as their experiments and what they dive into is they utilize GRPO, and then they train a model on three different domains, which makes it interesting, right? So they train it on puzzle, math, and code reasoning. So puzzles, math reasoning, and code reasoning. And then their overall takeaways, what happens from this is that puzzle and math data provide mutual support. So logical reasoning and mathematical capabilities complement each other and enhance overall model performance. I would expect that overall, right? Code reasoning has mixed cross-domain effects. It strengthens reasoning transfer for the instruct model, but may constrain the base model's reasoning capability. And they dive into this a lot throughout the research paper, and then like go into the kind of the negative aspects of that the code reasoning has on the model, right? That it's essentially training on puzzles and math data are very conducive to each other, that they work very well together. But with code reasoning, it's like kind of that does not hold. That code reasoning actually makes these models in a lot of instances perform kind of worse overall. And then the next thing is that cross-domain data leads to more robust performance. So combining diverse data often results in stronger or more balanced model capabilities, but requires more sophisticated design to address conflicts that may arise between different domains. And this is the hard and the challenging part within this, right? It's and the also the secret and benefit sauce of GRPO is that the benefit is that you get a more robust and more generalizable model, right? Like I've gone over this concept before on my channel. Like a lot of people, they group AI and they assume that AI is like not generalizable, right? But if we were to put it on a scale of like 0 to 100, humans would not be 100 on that scale, and AI would not be 0. So let's assume that like that humans are like a 20, 25 on the scale, and AI is like a 5 or a 6 on the scale. With GRPO, essentially, like and utilizing this method, it would be possible to maybe bump up AI a few percentage points on that scale, right? So if AI is currently a 5 or a 6, you could move it to like a 7 or a 8. or a 9. It'd be kind of like, yeah, like just being able to turn that dial just a little bit, right? Like ever so slightly is what you can do and control within that and how that works out. And then so next, the thing that they note here is that supervised fine-tuning boosts the effectiveness of reinforcement learning. So incorporating an SFT stage before reinforcement learning leads to substantial improvements in model performance. And this is something that we've known before. And then so when it comes to like alignment problems and alignment issues, and a lot of different issues overall. To me, like this particular aspect of this always stands out as a counter to that, right? To me, it's like there's always going like supervised fine tuning is the best base that we've come up with. Like it's not obsolete, right? It's not like all of a sudden it's like like there was supervised fine tuning and then it was like unsupervised and then now we're on reinforcement learning and then all these other methods just get completely abandoned, right? The best way to train these models is very specifically, and they dive into this a little bit deeper here, via a curriculum type of method, right? Which is very specifically where you start off like very easy and then you're giving the model like supervised data, etc., right? And then you slowly increase the difficulty and allow the model more ability to explore. And then that leads to a better model development overall. Then template consistency is critical. Misalignment between training and evaluation templates can significantly degrade performance, which also indicates that the robustness of RLVR's generalization ability is challenged when trained on specific domains. They dive into this in like a huge section of the research paper, but this template consistency concept is basically the drift or the difference between training and testing, and when it comes to the models. And then so let's say that I train the model on a bunch of problems that are like arithmetic, and it's 1 plus 1 up to 10 plus 10. And then if my template for testing is what is 20 plus 20, that is like there's going to be a lot of drift within that template very specifically, right? Because that's outside of the domain that the model was actually like trained on specifically. And then so this highlights a few things within that. It highlights one, that is impactful for the models, that drift does occur with GRPO. And then secondarily, what that means is that there is an upper limit as to that generalizability that you're going to get out of GRPO, right? Generally, it's going to be a few percentage points that you're going to move the needle, or you're going to move the you're slowly and slightly moving the needle, as opposed to like moving it into like a completely different ballpark overall. Then policy refresh benefits. So periodic updates to the reference model and optimizer state in curriculum learning can somewhat improve model stability and performance. And then that's, just kind of general across the board. And then next is reward design should adapt to difficulty. That goes into the curriculum learning. I'll dive into that when they spend a lot of time on these things. And then this last one is the most interesting part to me, one of the most interesting parts. RLVR is language sensitive. Models trained in Chinese underperforms that trained in English with a consistent performance gap. So to me, like this, there's a few things that I want to unpack with this. Like, so the very first question is like, why does this occur? And then what is it? So why would models that are trained in English outperform models that are trained in Chinese? And then so very specifically, like my very upfront and first assumption is that there's more tokens available for English training than there is for any other language, right? And then within that, my assumption would be that if you stabilize the amount of tokens that the model would have to train on within that specific language, and then it would account for and solve for that gap. The second thing I want to point out with that, and it's like I see this a lot, and I dove into this a bit myself for a while, right? Which is like essentially like creating a let's say if you want to get into the realm of creating a individual language for these models, like common examples would be like utilizing like higher order logic, or like some sort of like logic based language, right? Or based off of like first order predicate calculus, things like that, right. But the challenges and the problem that you run into with that is this same exact problem, right? So that method might be great, like it might be like logically allow the model to have huge gains as far as like understanding and the tokenization. But if there's not enough tokens to train the model on that individual language, like if you don't have trillions and trillions of tokens, which you're not going to if you're creating the language, then it defeats the purpose when it comes to these models very specifically, right? And that's what this to me highlights out, and all of my research within these things highlights. That's why I never dive into those things specifically, just highlighting that here. I noticed that within here, and so I just wanted to I made a mental note of it, and then so just highlighting that here. So let's go ahead and go through and dive through the research paper. So they do their multi-domain setup is their experiment, right? So then math, coding, and puzzle. What they found overall, the best blend was a blend of all three, right? So if it's training it on math, coding, and puzzle was the best performance overall. And then so that's like that generalizability aspect and allowing it to do that and train on that level on three different domains overall is what I like about the GRPO method, right? And then so that's why I keep going back to it. The problem, the drawback with the GRPO method is that it's just so new of a method and there's so little research that is available on it, right? This is one of the very first ones where, I mean, it's literally the first one that I've seen where it's on directly addressing this multi-domain concept, which is what caught my eye, because that's what very specifically catches my eye overall about GRPO as a method. But then so diving in, they dive into the individual domains, so math, coding, and puzzles. And then they dive into this performance combined domain, right? And then how that's kind of like the best overall. And then measure it out from there. And then they take their key takeaway is that this multi-domain training is kind of the best overall, right? That nothing beats it. And that like that's kind of how that goes over there and overall. And then this last part I wanted to highlight here, the section 7, right? So impact of reward styles on model performance. So this dives into like the different, so GRPO is very specifically dealing with the like self-reward mechanism and training the model to be able to self-reward on a verifiable reward, right? But then so you can have different verifiable rewards. And then this gives you kind of just the math behind it. And then very specifically like in this section 7. So if you want to like go through and understand like the math very specifically behind the rewards of GRPO methods, then section 7 there is really specifically for you. And then they come into the conclusion, and then they have like all of their benchmarks here in the appendix, right? So lots of results as to how they come about and what they're benchmarking across for the different individual domains, and then like examples of prompts that they used for their different games, etc. overall. So great research paper as a resource. If you're interested in GRPO as a concept, looking for more specific research papers with regards towards real world experiments, and then very specifically with regards towards the generalization of them, this is a great paper overall for you. If I were to offer anything as to like future works or next steps, I would like to see very specifically and kind of selfishly more research papers with regards towards GRPO outside of just standard transformers models, right? Like I'd like to see GRPO, more research papers around GRPO with, let's say, like diffusion transformer models, vision models, convolutional neural networks, etc. Right? Like more data around other architectures would be awesome. Overall and very beneficial, I think, to both myself and to the world overall. And so just highlighting that and pointing that out as kind of on my wish list and putting it out into the world. So if you like this type of content, please like and subscribe. Thank you very much.